Muy buenas tardes a toda la comunidad de ingenieros de sistemas. Nosotros hoy vamos a tener un ponente quien nos va a presentar en inglés, por lo cual yo también voy a cambiar a inglés ahorita. So we're going to have today a very interesting talk by Kirsi. Kirsi and I studied together a very long time ago in a galaxy far, far away, and I'm pretty sure she can get into more detail if necessary. Both her and her husband are very excellent computer scientists applying their skills in the industry. But before we turn this over to Kirsi, I'm going to have Luis Angel introduce her background to you guys a little bit so that you know a little bit better what she's been studying and what she's been working on. Luis, go ahead.
Hi. Ms. Kirsi Louhelainen has a master's degree in computer science from Helsinki University of Technology and has extensive experience in IT field where she held different positions such as software engineer, software architect, and CTO, and among others. Her areas of interest are software engineering, artificial intelligence, and cloud computing. She currently works as solution architect in Amazon Web Service. Ms. Kirsi, welcome.
Thank you. Welcome also from my side to this evening. I can't see you, but we'll be seeing each other later this evening with the questions. So today's topic is, I put it in a bit provocative way, so machine learning and AI in real life. And with subtitle, how to get value instead of getting academic exercise. I was just talking with Elisa about how your backgrounds, a lot of you have a very strong mathematical background, you up in the business world doing something with machine learning. And I think, and you also have understanding of software development. So I think this talk maybe could be very interesting to you. The talk today will be a collection of stories from a few years back of my experiences in developing real-life solutions with a bunch of data scientists, data engineers, and software engineers, and what happened when you put all those three together in a pot and put a kettle lid on. I will have a small slide about myself. Thank you for the introduction, but there are a couple of things I want to tell you. And number one is I'm actually not a data scientist. And as you were mentioning, I have been studying computer science and engineering. I started studies over 2 decades ago. I went to work first time at year 2000 and I never really looked back. But this is why my background and my point of view for machine learning projects is a very practical one. So I'm the one who's looking at it from operational point of view. I'm the one who's looking at it also from at times a team manager point of view. So yes, background in software development, I still love to code. And I recently started as a solutions architect at AWS. And here is the mandatory disclaimer. So today I'm here talking as an individual and as a friend of Elisa's, so not on behalf of my employer. Bit of a background. So the ways I've been utilizing machine learning, I actually like machine learning better than AI. It sounds too hyped. So I started first in a consultancy where I started building an internal capacity to do emerging technology. You know, this was time when Google Glass was a thing. So, you know, augmented reality, the tools came out, actually got that smuggled into the country since it was sold outside the US. We started experimenting with a lot of different things, IoT, and we realized that there was something that tied them all together, which was machine learning, because that was what enabled you to do something interesting instead of just visualizing something. From consultancy, I went to work as CTO with this fairly large size outsourcing HR and recruitment company. They had 4 different companies with the branch, so I was helping different types of companies to utilize machine learning data and digital tools overall. And this is also the place where I actually built a startup. After that, I've been also working as a consultant, again, helping especially companies who struggle with getting from their data sets to actually using them in developing their business. So what follows is essentially distillation of a few of the lessons learned along the way. And I hope I've been able to update them a bit, because I've noticed that even in the past year, the tools are advancing, the understanding of what tool is advancing. And I hope that at least a few of the things I mentioned you today is a bit familiar. But let's start with what exactly is the problem here? Why is there even a problem with machine learning? And I give you 2 numbers. I think the direction is optimistic. So I think only a couple of years ago, Gartner gave this number: 87% of proof of concept projects of machine learning never make it to production. Not a pretty number. Just like, yes, last year, the same number in Gartner was 53. So there is a big improvement. No doubt there is also weird data sets behind it. But the point is, even now, half of the POCs never make it to production. And those that do, on average, take 9 months, which is a lot, because that means it's way longer than you would want it to be. It's way longer than you would need it to be. It's good to point out that proof of concept is, of course, a proof of concept. You are proving whether something works. So you are not expecting this number to be 100. But it's clear that there are other issues that are related to operations, maintenance, tying into business processes, and just plain out how to make different types of professions work together. And a little clarification still. So what kind of project are we talking about today? And this is now, I know this is a very, very broad outline. I'm just basically clumping things into 2, which is, I know it's not pretty. But category 1, which is not going to be a topic today, is things that are productized. Typically, quite often, some of these, they use neural networks, not always. But this is about very specific tools about, if you want to recognize a cat in an image, you have pretty much the tools already available online. And if you need to integrate something that recognizes cats into your tool, that's possible. If you need to translate something, unless it's Finnish, which is still not pretty, if you want to forge a video clip, I could have inserted a nice video. My kids just sent me one of those viral tools. So I'm appearing to sing a video there. So yeah, there are pretty good tools available in very narrow fields, especially related to images, sound, translations. And common for these types of things, they are, as I mentioned, they are very narrow, but they also usually no need to integration, so they can be used as is. They're not interesting for now, because they also don't handle most of the things that will actually change, if not the world, at least a lot of businesses. And that's sort of the custom machine learning algorithms. And this is, the other name of this is the boring stuff. Because a lot of people, think about this. Automating accounts payable process in bookkeeping by automatically categorizing invoices. I've been doing this for a living at some point, and even I fall asleep when I say that sentence out loud. But these things, forecasting demand, predicting bankruptcy, dynamic pricing, estimating cost, these are all things that I've been working on at some point in previous years. They're all these pretty under-the-hood processes that will automate a part of business process. It's tedious. It's done with typically incomplete data. And typical for this is you can't do this with other people's data. If I'm automating my invoicing, I will need my own invoices, and I will need my own bookkeeping data in order to automate that. And if I don't, I think there is a serious data breach problem somewhere. So this is the sort of private thing that is going to be most efficient when companies are moving forward and actually starting to utilize their data. And I have to say that companies have been talking 10 years about how they want to be data-driven. Not all of them, not most of them are. But let's start with the story time. There will be 5 different stories, and I hope you enjoy them. So this is a lot of these stories I realized when I was putting this together are actually from one single startup. So this was when I was in this big outsourcing company. And we had created an internal thing. Somebody had realized that, okay, so the accounts payable process, it's costly, it takes time. And why do people click on this? Why do they categorize invoices into, why do they label them with accounts and cost center if this could be automated? So we decided to spin off a startup, and I was put as a flying CTO to build a team, decide how we will go on productizing the thing, then of course evolving the product according to customers, which we eventually got, and that's a whole other story. But what we started with was a library that was created in 2 months in isolation by data scientists with very little computer science background. And we were running, very big companies, $500 million companies, invoice data through this concoction of code, which was running in an unmaintained server, and which turned out to be eventually a security risk. And we actually built the company for about 6 months, and we created all the process around it, and we even got our first customer, external customer, before we realized we need to stop now, because we started to realize that it was depending on libraries that were no longer maintained. We weren't able to update it because it was too complex, and it was mixing up things that shouldn't be mixed. And so we gave a few weeks to one of our data engineers and said, okay, please look at this very closely and do something. Well, what happened? Oops, I told you the story there because I was. What happened was, first of all, he replaced literally with 3 lines of code, but it was immediately 5% more accurate. It turned out everything fancy that this data scientist had done. I mean, what he had done, he had recreated naive Bayes. I mean, this is algorithm from the 50s, statistical algorithm. And there was nothing gained from this. I know there was some things about efficiency, but this could have been solved by putting it in the cloud. So that was the fail number 1. Number 1 is you never need to develop, well, never say never, but typically you don't need to develop an algorithm to a problem, and you don't want to implement an algorithm to a problem. And of course, you know this. I mean, you have your Python and you have your notebooks and everything. You know that most machine learning algorithms, they are already in an open source library. And yes, you need to understand how to pick them. You need to compare. You might need to run them. But there's one fun thing here that we actually did an experimentation at that startup. So same data engineer who was replacing this complex thing with 3 lines of code and invocation of that naive Bayes. You also discussed this. We should actually automate this selection of the algorithm. So why shouldn't we just spin up processes in the cloud and make it run 100 times? Different algorithms make different parameterization. Run 100 times and tell you what is the best one. And we did try it out. We never took it to production, but in the coming years, for instance, AWS SageMaker does this for you. There are other tools that could do it for you. So in a sense, we are now also replacing some of the experience needed with tooling. And I think this is good. It doesn't make data science obsolete, but it means more people can do this. So, and the crucial thing here is, this might be obvious to you, but it's not obvious to people who don't do it for a living. There's also an exception, which is one of the customers I had. They needed help in completely different thing, but it was a customer, Finnish company running global warehouse optimization for many very big retail companies. So they actually had an entire department of data scientists, and if they could get 1% improvement in one single operation, that would mean so many euros for them. And in that case, they do need something on their own. So this concerns more about those normal operational improvements. But this leads me to story 2. So I did mention that this company had an excuse of having a roster of data scientists that making even 1% improvement was good. Well, the reason why I was helping them was that they had this issue that when they had this perfect code, it might take them a year to get it to production, because then they would hand it over to the data engineering team and the software development team. And it was a bit hit and miss whether they actually managed to reproduce the code and make it to production. And we had the same problem in the startup I mentioned. So at some point, we hired a data scientist full-time. We had certain problems we wanted to tackle that weren't just about improving data or just trying out different algorithms. We had some specific problems with certain types of invoices that had many rows that needed to be mapped differently, and different types of problems. And we knew the customers were asking for them. So the data scientist took a task. She took her Jupyter notebooks. She actually found pretty nice solutions. I was like, this is impressive. Like it was a nice improvement, not like maybe not 10, but several percentage points off the hat. And because we were talking at the time when we started the project, we got about a bit over half the invoices right. By the time I left a year later, we got 86% of the invoices predicted right. So this was the sort of the journey of that. And well, he took the code, the data engineer, and he started cranking, and it took a long time. I mean, he was essentially rewriting it in a different language, and of course there were different libraries, and it turned out it didn't work. It was actually worse than what we had in production. And this led up to a very interesting discussion of him saying, it just shit, this algorithm doesn't work. I'm sorry about swearing, by the way. I promise I don't do this again. And then, her blaming him about not being capable of writing code. And this is, of course, just a team problem. But this leads to fail number 2, thinking that you can just sort of leave this data, like things like this data science stuff. So one of the biggest things that we had to do at this point was that we had 2 data scientists at that point in the team, in addition to the data engineer. And they both came from very different backgrounds, but they both were very much not understanding about software development processes. And at the same time, we as a team didn't have the tools to give them that help they would need to do their job. We didn't have, for instance, they would say that, hey, I would need this data from production to my sandbox so I can do something, and even that was difficult. So software development, it has great processes already. People might fight over Scrum, over some other agile method, but don't care about it, because basically the basic tools are there, the processes work, it boils down to very few things. And you will work in a development team if you work in business. If you feel like you are in a data scientist daycare center, you're surrounded by other data scientists, maybe some else thrown in a mix, then you're probably in a place that doesn't know what they're doing. Or then you're doing something in that retail warehousing optimization company. But in the software development, the certain processes are so standard. And these are, I think, if I know anything about who's been teaching you, you know many things about this. So agile development processes, backlog. One data scientist came to the team with a PhD. He had done really great things at the university, and when I explained him this concept of, hey, we have this thing called backlog, and you take the thing off the top, and then you leave track when you're done. And he was like, wow, mind-blowing. So these processes, they need to be for everyone, not just somebody who's just doing code. CI/CD, continuous integration, continuous delivery. It has great tools. Version control. Even if you work on Jupyter Notebook, you will want to save your code at some point. You want to save it somewhere. Other people can see it. Other people can read it. They can run it. And this actually extends to what was your test data set. which makes it a lot more complex than in normal software development. And if you haven't checked out MLOps, so it's all about adding data validation, model testing, automated model integration testing. This boils down to you should not need a data engineer to rewrite your code to production. It almost never works, and when it does, it is very expensive. It takes so much more time. You will need a place where a person who does the model is able to put that to production, is able to test it, is able to maintain it. And the tooling is now so much better. We actually created from scratch a data pipeline. There were a couple startups doing it, but these days, cloud providers give you these tools. They give you, like SageMaker has great data pipeline. You can publish, many people can offer you, companies, the ability to publish your code to behind an API or test it out in a staging environment or revert back to old version if needed. So you will want to be responsible also of taking your baby to testing and to production and maintaining it. But we'll talk more about this later. Yes, so story number 3. So I mentioned we had a couple of data scientists to work on improving the algorithm since there was a lot to do. And at one point, actually, at the same time when we got a data scientist coming in, he also hired a data analyst to check up on the customer data. I mean, we didn't have that much time to look at it, and we knew there was something like funny. Somebody had to do something. The data actually I'm talking about, it was XML files. We had like tens and hundreds of thousands of XML files. Each of them was an invoice. This was supposed to be standardized. There is a very strict rules what you put there. But what she found out was that not only were there at least 3 different places where you officially could put certain important data values, there were also about 3 different places where you quite on a regular basis you found these same values, even though it was in the spec. Furthermore, she found that there were some import numbers, like VAT numbers of companies. You had 3 official ways of actually writing those down. And there was no consistency of which format anyone was using. In addition, there were pretty standard ways of misspelling them, and of course the non-standard ways. We also found out that our source of truth, which was the bookkeeping system that we used for actually training the model, they were missing half of the data we used matching, simply because they hadn't thought about it. It was supposed to be there, but just somehow somebody had not done that. So we actually had to do it for our customers. And this meant that we got, not only we got so much more information from the invoices, so it got the quality up, but we were able to match, I think, 50% more invoices, because we realized less than half of invoices were at times actually having the end of truth we could actually use for training. We just couldn't match the invoices because of lacking data. In 3 weeks, we got 12% improvement in our results just by fixing those issues with data, like the most obvious ones. In 3 months, the data science got us that 3 better results. It's not unimpressive. I mean, it's good. It's part of this very high number we got to eventually. But 12% improvement in 3 weeks after we had been working so many months in trying to do at least some improvement. This is not because the data scientists didn't do as good a job. This is simply because there were so many low-hanging fruits with the data. It was just, in hindsight, they were obvious, but you couldn't do it unless you had somebody who was willing to do the work and look deeply in the data. So in many cases, people still think that the machine learning algorithm is the thing, you know, although in most cases, it's, even in our case in this startup, we actually tried out and it was almost irrelevant which of the sort of classic algorithms we used. Almost all were pretty much the same. There was some variance, but not much. And the data was the problem. And I found this to be true for the most part. Of course, there's still, you do need to choose your method. You do need to choose the type of algorithm. You can't do statistical analysis on all the things, and you can't use neural networks for everything. But the quality of data is critical, especially in many of these business scenarios. But the good thing is that if you understand the business case and you work with domain experts, you can overcome a lot of issues with data. And I mean, sometimes you can just do brute force and you can do it for your customer, like we did. And typical ones, typos, human errors, discrepancies between systems, as I mentioned, specifications that are either wrong or are not followed. And of course, data structure changes on the fly, which is my favorite. It can kill everything. And I maybe like, this is a strong statement to say you can even overcome an almost complete lack of data. Well, not like almost complete, but you don't have to have that much data. If you have a use case and there is data for that specific use case, customer doesn't have to have everything in place, because sometimes getting some progress is actually enabling them to sell a more complete project of bringing their data into, let's say, a data lake or something, someplace where they can do more of the work. And yeah, just a reminder that of course we needed still data science work, but it was mind-boggling how much you can do with just the data. Story number 4. I haven't omitted the names of the guilty because this was publicly online in the internet. For the background, we've been renovating our home in the last couple months, and occasionally we need to stay the night away since, you know, people are painting here and they were redoing the floors and removing walls and whatnot. So once we wanted to stay one night nearby, I don't know if you are very well aware of the conversion rates between, you know, euros and pesos, but this 54 euros per night is typical for a hostel. An apartment should be maybe twice that. It shouldn't be, you know, 20,000 more times expensive. And what's funny about this is that this happened only a few weeks ago, but I actually consulted with this company. They were part of this conglomerate I was working for, CTO, and they had the same issue several years back. This is dynamic pricing, and which they had started developing initially first. This is actually a true story. There was this very famous Finnish musician, a singer, and once during an evening, he announced that he's going to have 2 huge concerts in this Finnish city called Tampere, and that's going to happen. I don't know if it was 6 months' time or even a year later. So next morning, people at Fornum, they came to the office and they found out every single apartment, hostel room in that city at that time had been booked during the evening. And they realized that, okay, they should have some sort of dynamic pricing. People could have paid more for the accommodation at the time and started developing, but they didn't have the first time they had some price anomalies where it wasn't this much, but there was, I was actually consulting them with this, and they had something that was testing the price and checking how it went, but there was no sort of fixed limit on how high you would go. I don't know what's the story with this one, but I think somebody might have put the wrong version there. This is not something you want your customers to see. So this is fail number 4, maintenance. And this is, I still see a lot of this, and I saw a lot of this at the consulting business customers. They buy a project, they buy something where you build something that they put to production, and they assume it's enough because it's running. And the problem is it might crash. The problem is it might drift. And here again, an analogy with software development. So regular software maintenance in production, it's a pretty well-known craft. It's not necessarily always easy, but there are certain things that you just know you have to do. There's alerts, there's debugging, there's health check, With health check, if you are in a cloud world, you might have standby instances. So if something fails, you are immediately failing over to your standby. You might even be failing over to another region. You will do regular server upgrades. You will update your libraries. And of course, if there's any security patches, you put them in practice. For those cases when this is not enough, of course, there is the customer feedback channels. There is the maintenance phone. And this is pretty standard stuff. The problem here is that although this is all good, when we come with machine learning, software engineers don't necessarily know what to do because there are extra layers of complexity. For instance, versioning of data is something that we have talked a lot over the years in different scenarios, and not many companies still do that. If you go to banking world and you have to comply with certain regulations, they of course know how to maintain things, but it's also very stiff. You might not be able to even change your model until every 6 months, and you have to submit that to an authority to check. But in a normal world, when you are not bound by regulation, you will want to be flexible in your production. Yet the default often is that you just forget the model once it's done. In the startup I've been talking about, we actually had we ran the model every day, because every day we were getting the latest invoices that were finalized. We got the final truth, and we were able to retrain the model. So we learned really fast, and actually we improved a lot, even like the first months, simply because we got so much more data. But where do you store your model? Do you version your model? Should you have, even if you serve, let's say you serve customers with this type of storage, you will have different customers using different models if they have different data. Those models could have been actually done with different algorithms, with maybe different kind of hyperparameterization. You might want to version and store older models in case something goes wrong. You want to make sure that you can retrain a model and automatically deploy it without anything breaking, and that means CI/CD practices. You will want to watch for model drift. Does it start to go astray? Does it really work the same way a few months from now? Does the data change? I mean, here one example we had in production was that the customer had given us data that had used null in certain field. We tested it, it was fine, we put it to production, and we were not able to predict at all one field, because it turned out they had in their production, they had 0 and not null. That's a very small thing, and you can find it if you know what to track and what sort of parts to add. We hadn't. Well, this is the final story. I actually had a few other issues too, but I wanted to keep this short. So I remember one time, and this was curious because I was talking with people who definitely understood more about analytics and statistics and finding things from data than I ever have. I mean, these were psychologists. They have half of the psychologist degree is about math and statistical analysis. They have really great tools, which are old, but they still work very well. I mean, they are the original data scientists to a degree. But we were discussing with the company that was doing personal evaluation, and they needed help because they wanted to have try out actually building something that would make evaluations of people without necessarily the personal component, something they could add to the recruitment software. And what it got a bit absurd because they were basically saying that, okay, so we have this one software and there is some data. And then I asked what other data you have. And they were like, well, we don't have other data. And at that point I thought, okay, so you've been in business 10 years and you've been interviewing tens of thousands of people. You must have CVs, right? And they were like, yeah, we have CVs. Are those data? I was like, yep, that's data. Then I started digging into it. Like, do you have records of who's been here? Do you have any like demographics? Do you know where they were placed? Do you have data of how they did? And it turned out they had a lot of data, but they just weren't sure what you could use. And it wasn't coherent, obviously. Some of that was on paper. Another time, this is also the same conglomerate. This was a construction arm of the company. And this was in Norway, and they had a problem. And actually, what happened was the person responsible of this company's construction operations came specifically to me because he said, well, I have a problem, and I think this AI could maybe be used to solve it. And well, we discussed a while, and I tried to ask what is it, and it turned out they had this issue of most of the profits in construction come from extra work. So you need this really low initial offer that you just cover the salaries, and then you do the extra work, extra contracts, which are the one where you get the profit. And people were not they didn't have the information about the extra work. And why didn't they have it? Well, because no one was writing it down. So I said, okay, it takes 2 minutes to make a Google form, which you can install as an app on your phone. You give that to your construction guys, you teach them to input the data, and when they learn that, let's see what we can do. So it's sometimes the maturity level is such that you don't even have the tools to do something. Sorry about the pun, but yeah, the lack of maturity is a real problem. But I'm not talking about bad jokes from data scientists. I'm talking about lack of maturity of companies and of operations. So lack of maturity of the companies you work for. And one example is that they would like you to do something with data that it turns out does not exist. Especially with the hype of the last years, the curiosity about AI, they always say AI and machine learning comes before the actual maturity to use it. Things have changed. I mean, many things I talk about here, they happened something like 3 years ago, and in 3 years, this has been leaps and bounds forward. And I think the maturity of many companies has grown. I've seen it I don't know how this is in Mexico, but for instance, in Finland, I've seen that logistics companies, those who drive trucks, they have finally started to use data. 3 years ago, if they used Excel, you were super happy. Now they're actually using dashboards. They are starting to use prediction, and they are ready to use. So typically, you first need to get started just gathering data. I have basic analytics. But as I mentioned before, sometimes it's maybe better to just get started with something small if they just have data enough for that. One thing that is, this is something I could have a separate presentation on, is you need to have processes where you incorporate the result of machine learning, something that you can act on, or something that can automate something. In this invoice automation part, for instance, we had an API you called with an invoice, it returned a number, and this was integrated. So you couldn't use it anywhere, but it was integrated to a couple big products, which had to have actual modifications in the UI. So we call it circulation software, which is what accountants use. And they actually had to have changes in the UI so that you could see the prediction, and it could be put immediately on the invoice when it was assumed to be good enough. Another example we did for one customer was they had a CRM, customer management software, and they wanted to have their information about churn. So how likely is this customer about to go? Because it's very expensive to get a new customer. It's much more cheap if you can keep the existing customer. And here we had to design, so where in this, which is the interface for which it goes to CRM, and where should we show it? And what happens when you see it? In this case, it was enough to show the number and actually show a few factors of why is this number high. And then people were able to just use that information or not, but it gave them just additional info. In some cases, you can just automate everything if you're sure. And the final bullet is it's not so much maybe organizational maturity than the level of knowledge with people. So I've been writing about matching CVs with statistical methods in a workplace, and I got comments on why do you destroy the world with your artificial intelligence. I mean, that's not like understanding of what machine learning is. But even like, especially when you start doing automation of jobs, I've been in meetings where people have been very worried that, is it that you are just going to take my job away? And in some cases, you are. The company I worked for with the accounts payable thing, they did let go a few people who were doing this before. They were able to mostly give them jobs elsewhere in the company, but the fact is that those chores were less, so they needed less people in that. So this is a delicate topic, and there is also the topic of whether you would actually automate something completely or whether you just provide the information as support. So that's more palatable, but it's also in many cases more secure because, as we mentioned before, if you don't have your CI/CD, if you don't have monitoring, if you don't maintain your solution, you will probably want that extra pair of eyes and a person to secure what's going to happen. Now, here's another little troll. So, okay, so this is all about working in companies, improving processes a little bit over time. But what if you want to do something cool? I mean, of course, you know this, but there are many places to do that. Some of those are in universities, but not necessarily there. So, for instance, in pharma, if you work with pharma customers, their systems are not at all like what I've described. They just need to run a model, and they will get an output, but it's not something that they will have to integrate to a product that will be shown to the world. And here is a lot more sort of data science type work. Of course, there's also a lot of domain understanding. But as I said, this automated pricing and forecasting, matching and price estimations, that is something that's going to happen. And of course, there are, for instance, in forecasting, you start to have now tools that can do that for tabular data. But there's still a lot of stuff that doesn't have these ready-made tools. So use the tools that you have because they are really helping you out these days. And try to have also a business understanding of how you can incorporate this in your software development process. I mean, if you go to work in a company and they don't have a way to improve data science, add the data science in how they do software, if that's where it's supposed to go, or if in the BI system, you should bring this up because otherwise you will be not necessarily getting as much enjoyment from your job if you are not getting what you do out in the open. And I think we all in the end want the stuff we do to be useful. Here, key takeaways. So here actually more, these are aligned with those examples, but more concrete. So when you are starting a project in a business, make sure that the first one is small. Make sure it's aligned with business needs, not something that you find it's possible to do, but also something that business actually sees the need for. But it's also something that has a very easy integration point. So if you have something that would be useful just by seeing a number when you're doing an action, that's a very easy integration point. If you have to actually start an action and automate a lot of things, that might be the second project. Don't worry if you don't have much data, but if you have at least the right data. And always understand the business case. You don't have to be a domain expert, but I mean, I've seen data scientists get ahead by leaps and bounds just after spending 2 hours with the business, understanding what's the logic. And be very curious about the new tooling, especially things like data pipelines, MLOps, code versioning, model repositories, tools for continuous model building. This is something that's going to save your life one day. And use code repositories when you do. I mean, even if you think an outcome is not yet the best, you will want to save your intermediate work because, let's face it, the next iteration might be worse. And try to learn how software development works, because when you work in a team, even if you are doing slightly different thing, you are part of the team and you will have that common thing. I added a couple of things to ponder, which were related to model transparency and trust. Maybe I can just briefly mention this. So one thing that was evident in my last job, where we had business that was doing serving customers with a lot of data analytics needs that needed also machine learning produced information, was that we needed model transparency in the sense that we would have to produce reasons for why an outcome came. For instance, if we gave a churn number, if you are a mobile operator and we say that, hey, the potential for this customer is to leave your service in 2 months is 87%. Sure, it's good to know you could put an alert, but what are you going to do with the number? So if you can find those factors that went into this number, you could say that, hey, the customer had 2 outages in the last 3 weeks, and they have been contacting your customer service already 3 times, and at least 2 times they didn't get a resolution. And suddenly you know a lot better what you might be able to do to prevent churn. And trust is another, and this is why I was mentioning that sometimes it's better to have humans with the information, not automate everything, but just give information to people in addition. This enables them to trust your outcome, because trusting what machines do is surprisingly quite often the reason why certain projects don't go forward. And after you've been yelled at in a little meeting room by people who are really afraid of an algorithm ruining something, you know this. But with this, you are ready to run. So thank you. Any questions?
Thank you. We have tons of questions, and I'm gonna try to match the questions to the stories so that we can kind of like revisit every single one of them. For the first story, Alberto was interested in how feasible it would be to try to kind of like put most of the things like behind like an API of services, so that when you have to implement one of these things, you just kind of like call the data engineer's code instead of like messing with it directly.
Yes, I had to check what my story number 1 was actually. So about the API, yes. Well, this was more about not doing things from scratch yourself, but about the APIs. I think they are a solution for many things. For instance, those about 2-3 years ago, we seriously considered putting all the machine learning work on top of a platform developed by one startup. And it was based on the premise that you could still use, they use like Jupyter notebooks for training, but they were sort of in secret always put into version control. And with the push of a button, they were creating an API that served the model that came from that. And then they versioned the API. So you were actually able to, you had the URL for the API, and you had several of those for all iterations. So you could anytime, for instance, just go to staging and test whether this was a good model that you could use. So yes, I think APIs are actually really, really good and powerful way. They allow you to version, they allow you to isolate. And actually, I mentioned we built our own data pipeline. That was sort of, the whole point was that we would have this like literal pipeline. So we would sort of add where one customer's data would come in. We will say, have a trigger that says, okay, so this data is going to be trained with this algorithm, and then it would, the result of that would go to the next part, and it would be served through an API. And the idea was that we could swap what was behind the API anytime. So if there was any sort of problem, we could just sort of go back to the previous model. We didn't get all the way to this fancy model by the time I left, but I think it's definitely a idea.
Yeah, and myself very kind of like in favor of of kind of like separating what everybody is working with, because when everybody's touching everybody else's code, you just break things way too fast.
Yes.
Arturo wanted a clarification based on the story one. So would you think that like when businesses have these kinds of problems, it's about 1% of the time that you like actually need like a scientist to solve it, and the rest of the time it would just be like engineers and common sense?
Yeah, I think in this case, I would say that when I started there, they actually had a leadership that was very strongly about advocating AI, and I think it was a good thing in many occasions, but it was also led to some scenarios where people would assume that AI would solve everything. But I think yes, especially these days when you have better tooling, you don't have to do such complex things anymore. You don't have to go create your algorithm from scratch. I sort of omitted some information there. So I think one part of it was that it was supposed to run in a server that wasn't very good. So I think there was also a whole lot of this optimization work that was done because of it. But of course, you know, one of those things we did was we moved it to cloud, which meant that it was irrelevant, like whether there was any savings in efficiency. Well, not irrelevant, but cost factor wasn't very meaningful.
About the second story, Pepe wants to know if you would just suggest like using like microservices in the backend for production. Would that be something you'd say that makes sense?
I would say that even this whole data pipeline idea was based on this idea of microservice, and this sort of goes nicely with this question about the APIs. So what we had was that, and maybe I clarified, this is why I talk so much about having to understand also other people's roles, is that we actually had software engineers that were very used to doing things a certain way, being very careful about not ruining production. And the things they were concerned about was, for instance, that the model was created using different language than the other parts of the software. And they were also concerned that that they had hoped that they would have some sort of like, they would be able to read the model code and evaluate that. And I tried to explain, okay, so what is coming out of this is a matrix. It's just something that, it's not the code itself that's going to be in production. But this is exactly why we thought that having that behind the API means that it takes away this fear of having different kinds of parts in the production, and also giving us the flexibility of cutting it off immediately if it doesn't, and also being able to test it in the development and staging and then putting it to production. So I think at least with the data scientists we had, like it was some work to discuss this whole idea of, so we first put in the test environment and then we put it in here, we test a bit more, but it worked really nicely.
Yeah, I've also run into a lot of people who have kind of like conceptual difficulty with this, that you could have a solution that's not developed with one single tool, but you can have like bits and pieces, and you can have one thing that feeds a database and another one reads from it, or like several ways of coupling things together. And it tends to make things easier than kind of like forcing the same exact language on every single component, because some stuff just really isn't meant to be. I once saw a dude who wanted to make a search engine for like web stuff, and he had decided he wants to make it in C++. And when I was trying to figure out why he wants to make it in C++, he just liked C++. It didn't really have any benefits for what he was planning on implementing.
Yeah, and here we come also to the fact that if you think like what is the language that you usually build models on? It's Python. It's not because Python is the best language, it's just because it happens to be there, it has the best libraries. Yeah. But I wouldn't necessarily want to build an invoicing application API with Python. I find it a bit queasy. So we had actually Scala for that, and I think that was fine. But what was important to understand also for the software engineers was that you couldn't just teach data scientists Scala and be happy, because Scala just did not have those libraries.
Exactly.
But yes, I think microservices have been really like making a big entrance in the last few years. So I think these days it's a bit easier to talk about it. And also in the cloud, you start having these, functions and lambdas that are also like really isolated microservices. So I think this is sort of a new paradigm, and maybe containerization is also helping to understand, hey, you can have this independent entity running somewhere.
Mm-hmm.
But yes, there is still a lot of also questioning for that in some parts.
Yeah, because when you have like independent things running separately and they need to talk to each other, you get to all these like synchronization issues that you can't just like call a function and get a return. You might get a promise, there might be a delay, it might never show up. So some people are reluctant to have to learn the concepts, like how do you make sure that a distributed asynchronous system is actually doing the same thing that it would do if you're running it locally on like a single core, single RAM situation. We have another question about the second story. Alberto is interested in what you do with the testing code. Like, do you have a separate branch in the repository for version control for the testing code, or where does it live?
Yeah, I don't actually even remember how we did the branching in that particular project, but we did have always test and staging and production environments. And the first round is always on computer, and then you move to test environment. The staging is obviously the one that is closer, like as close to production as humanly possible. So usually you would develop, I think we were also in this project so that you develop in a branch for a feature. However, the point here is that when we were doing data science work, that's more explorative. Here we had some issues of really like encouraging data scientists to have their repositories, and this was why we are also exploring these tools that would sort of make it automatic. I think the problem here is that with some notebook type things, they don't really encourage this. And this is me coming from software background, so I'm like, how can people do this? So you have these independent blocks and you can run them in different sort of order, and to me it seems like a bit even sentimental. Okay, it's like unorganized. So to me it's very important that whenever you have even a little improvement, you would immediately save the code to another system. But when you are done with the model, then you of course put that with that API to those same environments and just test it from there.
I'm usually very happy letting my students like explore stuff in a Jupyter notebook, but when they get to the point that they're like, oh, this instance runs too long, can you run it for me? I'm like, not like this. I'm actually going to want like a source code file that I can run in like batch mode. I'm not going to be clicking buttons on a browser to run this. And sometimes when they try to make like a batch runnable version, it just really doesn't do the same thing as they did, because they had been running stuff out of order. And when you try to run it like linearly, it actually doesn't work anymore because something was changed somewhere and it doesn't do the stuff that it used to do. Yeah. So I agree with you very much that they're fun for the creation part, but when it's actually supposed to be running, please don't have it in the notebook anymore. For the third story, Alan is interested to know what was the particular problem that the data scientist found with the data?
Wait a minute. This one. So the time and Ganels got the 12% improvement. The data scientist got a bit better. I think data scientist was maybe figuring out which ones were which factors actually were influencing more the results. So there were, I think she was experimenting with weights. And then I remember also that there was also some clear improvements with using, I think this graded boost gave a slightly better result, but then the problem was that it took too long for our biggest customers. So that was the part when we started talking about why we actually use a different algorithm for different customers, which really forced us to think about this whole API thing.
I could really identify when you were talking about the people who were mixing up the nulls and the zeros. I've had to deal with this so many times, that people want to be like analyzing something like crime rates. And then they're like, crime rates are falling. I'm like, actually, they're not. This municipality hasn't reported any data in the past 4 months, but it doesn't mean it's zero. It just means it's not there and you cannot average it in. And then we get into huge arguments because according to them, zero is the same as no data, but it's just totally not the same thing. Luis Angel,
typical if you get like, sorry.
You go ahead.
No, I just saying this is typical if you get data from somebody sort of in advance because the expert is working something that's different than what you get in production.
I've also run into a lot of data where they use something like 99 or 999 for missing data or -1. And I've just spent so many hours trying to explain to people why you cannot put a number as missing data. Like we had this one thing, it was a sensor measuring the amount of rain. And it said 99.9 whenever it didn't have any data. But it would sometimes have true values that were higher than 99.9. So it was very confusing to have the 99.9 as the fake data. It's just, it's amazing what people do when they don't have to analyze the data, when their job is only to record what values are given. They do the weirdest things. Luis was interested in knowing that when you do maintenance work, is it usually like manually done, or do you try to automate it with like scripts or something to like go through a certain sequence of steps to do maintenance?
Well, in maintenance, you should automate everything you can. And of course, this is easier said than done. But if you think about like just, for instance, APIs, just having a health check, that's very easy to put on automation. One thing we did in the startup was we had a dashboard. So we would have a live view of how many invoices were going through the system, how many of them were, estimate how many of those had gone, and we had gotten final value, and we would get sort of real time. Well, it wasn't real time since it was batch run from those end results, but we would also see like every day, okay, so this is how well we did. So we would also sort of catch things like, okay, so suddenly we don't see invoices going through, so there's a problem somewhere, or that we see that the prediction rate's going down dramatically. So there, in which case it's typically a data problem. So the answer is you automate. There isn't much really you should be doing manually apart from maybe like having a dashboard that you can look at. So if you can automate, you do that.
Yeah. Uriel and Beatriz have questions about the last story. Uriel's interested in knowing what do you think is the best way to break it to a customer when nothing can be done? Like with the data they have, the thing they want to do, that you can't do it. Like, how would you break this to them?
Well, I think typically, and this is of course for me, it's a bit easier because often I'm seeing this situation as a consultant who is expected to give a bit larger, so they are larger pictures, so not just like, can we do this one thing? But quite typical at that stage is that I'm saying that we are a bit far from being able to do these things that you want, but let's craft together a roadmap of the steps that you can get there. And then if people usually know their organization pretty well, so they know, for instance, if there is a need for a very sort of quick win, that's actually quite typical. So if there is something that you could do that you, for instance, I don't really like, I mean, data warehouses are necessary, but they are very complex endeavor, and you don't start there. But for instance, if they have any data somewhere, they could take the data lake so that something could be done. At first, they could just like follow it and display it, and then they could make a prediction based on it, or depending on what the data is. So for as long as you are giving some hope and the timeline, I think people are taking it pretty easily. I mean, in the end, they usually just want you to solve a problem and not. And hearing about a new technology just keeps sort of the incentive to come to talk to people. But for as long as it will eventually be handled, it should be okay.
In your experience, about what proportion of time the client actually wants to do the thing that's convenient to do, and like how often do they want to do something that you can kind of see that what they want to do isn't really what they should be doing? Like, do they ever ask for the wrong thing?
Well, 80% of the time. No, I'm slightly joking, but I think it's not a surprise that, I mean, I've been working in a number of consultancies, and the most typical sort of the flying phrase is that you don't give the customers what they ask, you give them what they need. So typically when they come in with the ask, you have to ask questions and dig a bit deeper about why is it that they are asking this particular thing. And that's just like very typical consultative thing. And this is also something that is very helpful, even if you're not a consultant, but you are working in a company. People will have an idea of an outcome, but especially if they don't know details of how to reach that, they will sort of ask something close, but not quite.
It's pretty common in software engineering that the clients keep asking for things that aren't really the things that they require. Would you say it's more common or less common when like AI applications than in like, let's say, traditional software development? Do people have like a little bit more like illusions of grandeur when it comes to ML than when it comes to like regular software?
Well, I think there is this assumptions about what you can do with machine learning that are a bit beyond what can be done, especially given the data we have, but also the tooling we have. And of course, I think the problem is that, or maybe let's put it this way, especially in the past years, there was a very big hype. I was, for at least 3 years in a row, I was saying, okay, next year there will be less hype, and there was always more. And when people hear about, people were talking about like general AI. I mean, come on, I've been asking in AI specific groups, okay, so does anyone know any project that is going any closer than this or this like very specific one, and no one knows. And I don't think it's going to happen in my lifetime. But when we have these grand visions, people assume that it's going to be much easier. And so yes, but if you explain what it means, then it usually goes much easier. I do find it kind of like funny anecdote that in one project, which I mean essentially it was just about very little about algorithms and much more about analyzing the business case and data. The business people were always saying like, we have the best AI minds in Finland, and it's like, yes, it is a great team, but the AI has nothing to do with the like solution. Well, something, but not that much as he thought.
What Betty wanted to know is, do you think that businesses usually get the kind of like the incentive to use AI on their own, or is it easier for someone from the outside to point out that maybe they should consider exploring some artificial intelligence solutions?
This depends, but especially in the last years, I found that it was very useful especially if there was curious about what do you do with data. It was simply to have, and this is actually something I did a lot in my past employer. So we would have a workshop. We would ask a customer to bring, for instance, one branch or one operative group of people, and we would first go through short introduction of, okay, so what is machine learning? What can you do? Give a few examples from their domain, and then just start brainstorming. And this sort of work there is always people have these very good ideas what to do with their company, and they need an outlet for that. And when you give them like an actual tool that they can use, they will actually brainstorm really cool stuff. And then what you can do as an outsider, you can then help them to choose the best ones, to go dig a bit deeper, think about, okay, so is this costly? Do we have the data? Is this easy to integrate? Which are those questions I talked about earlier? And this way you can actually find those first steps to take. And this is something that you can do also as an employee. This is something I think this type of approach might be something I've seen, like sort of if you have a dedicated data transformation person in a company, they might do this as well. So this type of workshop is pretty common now, and I think it's been very useful.
Also, Gerardo wants to know that if you're working with a company who's expecting you to make like this very fancy high-end machine learning solution, but they don't actually need one, They just kind of need like a cleanup script for the data and like a simple thresholding rule or something. What would you advise? Like, how would you advise kind of breaking it to them that you don't really need the thing you want, that what you want is it's basically a bash script instead of a Python model?
Well, here I think it's the best idea is to get started about, okay, so what is necessary to get the job done, and to bring up the cost factor, and then also whether it's actually like whether there's any additional value. So will this be more accurate? And here I think also the facts help. So if you know, for instance, that something, well, let's say that you just need a threshold for certain thing, that might take you very far. It might even be that, okay, let's say that this is value of a piece of equipment, I don't know, a temperature or something. I mean, it might be possible to create a predictive algorithm for an issue, but it might be just never be very useful compared to just always tracking the temperature and creating an alert. So I think the cost is typically, especially in business, it's a very good factor. But yeah, I've met customers where you might explain that this thing is too fancy for you. You might want to consider this cheaper thing, and they will say, well, okay, well, present us both, because they just really want the cool thing. And so sometimes over-engineering happens.
But would you say it's ethically okay that if they really want the expensive thing, that you should just like sell them the deluxe thing, even if they don't need it?
I would say
kind of like fancy handbags that people will pay hundreds of euros for a bag that looks just the same as a 25 euro bag for like reasons. Should we do that as consultants as well?
I would say that in this kind of scenario, it's usually helpful to suggest a step one. So, you know, we can get in this time frame, we can get this, and then we might, as I said, the cost is a factor. I mean, in business that usually works with people, maybe not so much. But I would say that this breaking things down into this is fast and smart, and this is a good first step, and it's not taking away from anything, is a good one. And I would say that often is enough. And then you can say, hey, actually, with this budget, you could do something else, because at that point you might steer it into a better direction.
And I think it might also give you like a better image as a professional, better reputation, if you just don't like oversell weird, kludgy stuff, but you actually kind of like scale the project down to what it actually needs to be. You might be getting a good chance to do the interesting, expensive project later on. But if you inflate it and like sell them some unnecessary things, someone's eventually going to catch on that you just made them pay $1 million for an if-else clause, and they're not going to be very happy with that later on.
We have a couple of projects like that in Finland right now. I just heard about some feedback from our very new healthcare system in the region. Let's not get into that. That makes me feel bad.
Yeah, but no one's going to hire you, and nobody's going to want to work for the company once it gets out that you're just basically stealing. But it's too easy. We've had those scandals here as well. Like the government pays somebody's cousin an enormous amount of money for a really simple web app that you could make in 15 minutes.
Yeah. But I would say that this is actually something that is really old also in software engineering, in that I think there was, in the time I've been in business, there's been like the past 20 years, it's been a big rise of sort of small, medium-sized consultancies. And there's also been a big rise in sort of maturity overall in companies about, you know, not just data, but digitalization overall. And I think there are certain old companies that are very much about sort of hemorrhaging the money and taking whatever they can. Of course, people who work there might disagree. This is just my outsider view, but I think there is a very, at least here we have seen a very strong tendency of this smaller companies that are saying that, hey, you don't need all these complications, we can do this. They might be a bit more expensive per hour, but they can actually do the stuff better. I like that.
Okay, this has been extremely interesting. I know we could go on forever, but you actually need to get to bed because you're on the other side of the planet. Yeah. So I think we'll we will call it here. I'll pass the stage again to Luis so that he can thank you formally in the name of our study program. And thank you very much from my personal behalf, Kirsi. This has been very, very useful. Thank
you for the invitation. It was fun seeing you and talking to you again. My experience has been helpful for you.
Universidad Autónoma de Nuevo León, through its Facultad de Ingeniería Mecánica Eléctrica, present this certificate to Kirsi Louhelainen for her participation with the talk ML AI in real life, how to get value instead of getting academic exercise, in the first 2021 conference series of the graduate program in system engineering. Alere Flammam Veritatis, March 26, 2021. Thanks for watching, thanks for the talk, and happy holidays.
Thank you. Bye-bye.